Hello, everyone, and welcome to the free GMAT Prep Hour. So excited to have you here with us this evening. The free GMAT Prep Hour is something we do here at Manhattan Prep every 2 weeks. We want you to have an opportunity to come learn from our experts on a wide variety of topics, so we cover a different topic every time. So, great to have all of you with us. If you click on the chat window, feel free to say hi. So just try this out. Tell us where you are dialing in from. I am dialing in from the Manhattan Prep office in Chelsea, in Manhattan, New York. Where is everyone else dialing in from? All right, we got Texas. Ooh, Maryland, that's where I'm from. I was raised near Baltimore. Toronto, Richmond, got folks coming in from all over. So excited to have you with us. So you are welcome to watch these, to attend live for free every 2 weeks. You're also welcome to watch any of our videos on YouTube, on our YouTube channel. I will give you guys that link later. But here is what we're getting into tonight. We're going to talk about how to approach data sufficiency, but I imagine a lot of you have done some data sufficiency before, so what we're really getting into is recognizing patterns in data sufficiency, because that can help us move more quickly, avoid mistakes, things like that. So let me hear from you guys. How many of you feel like data sufficiency is a struggle or something that you sometimes mess up or get wrong? I know that a lot of folks, especially in the beginning of their process, find data sufficiency a lot more difficult than problem solving because it's really a different thought process, requires a different approach. And Maddie says, struggle city. I love that. Yeah, this stuff is really, really hard. Or as some are saying, on the harder questions, this stuff gets really difficult. Yeah. So for any of you who've never seen data sufficiency before, I definitely recommend going to the Manhattan Prep blog. We have lots of articles that take you step by step, but I'm just going to cover the basics in case there's anyone out there who hasn't seen them before. So the absolute basics, you'll get a question, you'll get two statements that are trying to help you to answer that question, and then here's what we want to know about those statements. They're always true, they can't contradict each other, and they're trying to help you to answer that question. So this is what the answer choices look like. Your job is to figure out if you have enough to answer the question. So just as a little warm up here, try this one out and send me a private chat. So instead of sending it to all panelists and attendees, switch that in the chat box to send it to just panelists, and that'll send it as a private chat to me, and let me know your answer on this one. All right, so the important thing that we want to do here is we want to think about what the question is really asking and then not fall for the GMAT's traps when we're trying to figure out if we have enough to answer those questions. So we're looking at what is the value of x. If you looked at this first statement and said, oh, well, x, if x squared is 16, x is 4, yep, that's sufficient. And then you look at statement 2 and you're like, wait, x is negative. Those contradict each other. We just said that they weren't allowed to contradict each other. We need to make sure that we're not falling for the trap here. So the trap, of course, if we have an even exponent, we need to be thinking about plus or minus. So it wasn't x is 4, it was x is plus or minus 4. Well, that doesn't answer the question about the value. That gives us two possible values. So that actually was not sufficient. Statement 2 on its own, just knowing that it's negative, is not going to give us a value for x. But if we use both together, that clearly gives us x must be -4. We have our answer. All right. You guys are all experts at the basics. Nicely done on that. So just a couple things to point out about these answer choices. They're always in this order. You want to memorize it. And this actually makes data sufficiency really different from problem solving or from anything on the verbal side. I guess aside from sentence correction, A means something special. It's the original. But on any of the other question types, you can think of A, B, C, D, and E as being just random in order. There's really no difference between them. But with data sufficiency, the ordering of the answer choices as they relate to the statements is meaningful. And there are patterns that we can look for. There are traps that we can learn to avoid. So what we're going to be doing here is we're going to be looking at a series of problems that all have something in common. And I want you guys to see if you can figure out what they have in common. So we're going to be doing a timed set. This, by the way, is something that I really recommend that you guys do on your own. When you're practicing, it's not enough just to grab the official guide and flip it open and do problems however you want. If you're not practicing under timed constraints, it's going to be really hard to then move to the really, really constrained timing of the real test. Any of you guys have trouble with timing on the real thing? I definitely did when I started studying, seeing lots of yeses come in the chat. That was my biggest struggle when I was studying, is how to get it all done in time when you feel like there's a ton of work to do. So one way to improve your timing, practice with time sets. Another way to improve your timing, learn to recognize patterns so you can learn to guess better. And yeah, someone was saying that you guessed on the last 5 questions on the real thing. It really, really has an impact on your score if the time runs out. So what I'm going to do is I'm going to give you a set of 4 questions to do all together. Again, I want you to send me your answers in private chat, not in the main chat, as you go, and give me the question number and the answer choices. But if you need help, if this is kind of the first time you've done this and you forget what the answer choices stand for, here's a little mnemonic to help: 1, 2, 10. And I'm going to give you, let's say, because data sufficiency, sometimes you want to do in a little bit under 2 minutes apiece. Let's say I'll give you 7 minutes to do a set of 4 questions. Any questions from me before we dive in and start doing that? If you want, go ahead and pull out your phone and you can set the timer yourself on your own phone so that you know how much time has gone by. But don't cheat and use your calculator on your phone, because definitely can't do that on test day. Alrighty, we are going to dive in. 7 minutes for these 4. Go for it. You're halfway through, and don't forget to send me private chats with your answers as you get them. One minute left. And I'll just say I don't have any perfect responses yet. No one has given me all 4 correct answers. So that means these are harder than they look. All right. I gave you a little extra time. I gave you almost 8 minutes on that because this set was even harder than I thought that it might be. So first of all, give yourself some credit on this. I'm gonna take the questions away for a minute so that we can all collectively take a deep breath. It's nerve-wracking to do a lot of problems in a row, right? You kind of feel like you start tensing up a little bit. So make sure to breathe, relax, roll your shoulders out so that you don't let that tension in your shoulders cause anxiety. So yeah, this was a hard set of questions. And like I said, Nobody gave me all correct responses yet. Not that I've seen all of them. There might be a couple that were just coming in, but this was possibly harder than you thought it was. Some of these might have seemed easier than they were. The other thing that I want to point out is make sure in data sufficiency that you are answering according to sufficient or insufficient and not according to numerical answers, like the answer is 2 or the answer is 3, that kind of thing. So what I want us to think about as we're reviewing these is what they might have in common. There wasn't a topic that was common to all of them, but there's something structurally that's common to all of these, and I want us to explore that, see if we can. So, coming back to our set of problems here, let's take a look at this first one. Purchased 3 new books at an average of $15 a piece. What was the median price of the book that she purchased? So if I were annotating this, here's what I might put on my paper. One thing I often like to do for average questions or median questions is kind of draw out the slots and say, okay, well, we're looking for the middle term. So do we know anything else from the question stem? Not really, right? Just know that there were 3 books, we're looking for the median, and oh, hey, we know that the average, they give us that the average is 15. That actually allows us to infer something. If we know 3 terms and the average is 15, then yeah, we know the sum. So we could say that these all add up to 45. That could be helpful. All right, so looking at the first statement, she bought a book of poetry for $13. All right, well, we certainly could think of that as the lowest term. So it could be 13 and then 2 other things that add up to 45, right? The one that probably comes to mind most easily, especially if you glance ahead, which you're not really supposed to do, but we can imagine 13, 15, 18 equally spaced with 15 in the middle, right? In which case 15 would be our median. But could you also imagine, would it be possible for 13 itself to be the median? Well, we'd want to play around with the numbers a little bit and see if we could think of 2 other things that added up to 45. Let's pick something smaller, 10. And then what would the third term have to be if we had 10 and 13 and we're adding to 45? Right, so together these would add up to 23. So if we want to add up to 45, we'd need a 22 here. So we can think of an example where 15 is the median. We can think of an example where 13 is the median. So statement 1 was not sufficient. So in terms of our answer choices, A, B, C, D, and E, if statement 1 is insufficient, we can actually rule out 2 things. We can rule out answer choice A. We can also rule out D, exactly. So A and D are out. We've got B, C, and E left. If you said to yourself, well, just knowing one term was not enough to tell me the median term, so A is out, but then also like B is out, so if I use them together, then together it's definitely 13, 15, 18. That works. It's got to be C. I want you to be really careful about applying the same logic, about saying, yeah, same thing for statement 2. Because statement 2 might be subtly different from statement 1. So let's think about this. Knowing that the novel was $15, is it possible for the novel to be the lowest? Well, We know that we've got to add up to 45. If one term is 15, then the other two terms have to add to what? To 30, right? Well, is there a way to get the other two to add up to 30 and still have 15 be the lowest? Actually, yes. Trick question. What if they were all the same? If it was 15, 15, and 15, then technically 15 is the lowest, but you know, it's also the median, it's also the highest. So keep in mind here, so either they're all 15, in which case 15 is the middle, or we have 15 in the middle and then something lower on this side and something higher on this side if those other two terms are going to add up to 30. So in fact, on this one, the answer was B was sufficient, or statement 2 was sufficient, but statement 1 was not. And notice here that it didn't have to be that the novel was the middle term, but we're looking for the median price. So if they're all the same, 15 is still the median price. All right. Let's move on to the next one. What is the value of x minus y? I'll tell you guys, I had a lot of responses here for C, using the two statements together. And you know what? Hey, using the two statements together, well, here we have an x and a y, and here we have an x and a y, and we know that the rule that we were taught back in high school is if we have two variables, we need two equations to be able to solve, right? That is the rule. Makes sense. I mean, that's true, right? But doesn't that feel a little too easy? There's something about that that feels a little too easy. Oops, did I just stop sharing that? My mistake there. Let's come back to here. So there's something a little bit tricky going on. Do we need to know what x is and to know what y is? We don't. I don't care what x is individually or what y is individually. All I care about is finding the value of this expression, this what we like to call a combo. So I'm trying to get x minus y. I'm not trying to get x and y individually. So I look at statement 1. Well, statement 1 doesn't give me x minus y. There's no way to turn an x plus 2y into an x minus y. But what about statement 2? What if we subtract 5y from both sides here, minus 5y, and we'd end up with 4x minus 4y. And you know what? I can stop right there. It's equal to something. If I divide both sides by 4, I'm going to get x minus y equals something. I don't care what. So here, the answer was B, because the question was not asking for the values of the variables individually. It was asking for this combination, and we could get it with one of the statements alone. So, all right. There was a question about the previous problem that was asking what if 15 were the highest term. So on that one, if we think about the idea of the other two need to add up to 30, the same logic would apply. It could be the highest only if the other two were both 15. All right, now we're getting into seriously hard questions. This stuff is really tricky, and if you haven't covered units digit stuff yet, you might not know about these patterns in units digits. So let's actually do this quickly. Let's take a look at how units digits behave. There's a rule that says that units digits will follow certain patterns. So if we think about it this, like, what happens if I square 13? 13 squared, okay, well that's 13 times 13. And when we're looking at that, we do 3 times 3, well that's 9, 3 times 1 is 3, and then we drop a 0 and do other terms here. So when we add all of that up, the units digit here, the units digit of the product is the same as the product of these units digits. So 13 squared is going to have the same units digit as 3 squared. So when it comes to units digits, you can ignore everything but the units digit. We don't care about anything else. And it'll follow certain patterns. So if we look at 3 to the 1, obviously, units digit is 3. 3 squared, units digit is 9. 3 cubed, just give me the units digit of that, not the whole thing. What's the units digit of 3 cubed? 7. And then when we're looking at 3 to the 4th, we can just say, well, it's going to be 7 times 3 because we ignore everything but the units digit, so that'll end in a 1. And so that means by the time we go to 3 to the 5th, we swing back around. 1 times 3 is 3, so we repeat. It's like we're back to number 1. So the cycle will repeat every 4. So if we have 3 to the 4x, where x is an integer, we know that that's going to end in a 1. So using that idea, let's come back to here. N equals something something 3 to the x, something something 3 to the y. Let's just ignore everything else, and let's just look at our units digits. So let's rewrite this as 3 to the x, 3 to the y, because all we care about are units digits anyway. Okay, these are variables as our exponents, but it doesn't matter, right? Because when we're multiplying, all we're looking for are the units digits, right? So if we have 3 to the x times 3 to the y, we could rewrite that using exponent rules. When we're multiplying with the same bases, we add our exponents. So 3 to the x plus y. So if we want to know what the units digit of 3 to the x plus y is, what do we really want to know? Well, all we need to know is what is x plus y. This is our rephrased question. If we have the answer to that question, then we'll know what power of 3 we're looking at, so we'll know the units digit of this product. So in fact, statement 1 was sufficient, statement 2 was not, and so the answer is A. Almost everyone who rang in said C here, and you know, that kind of seems to make sense. This is a really, really hard question to rephrase, but if we think in terms of ignoring everything but the units digit and then doing it with exponent rules, rephrasing gets us to A. Oh, someone asked me to explain this thing that I was talking about with the 3 to the 4x. So what I was saying there is if we go like, okay, 3 to the 4 is 1, 3 to the 5 is 3. If we're repeating, then 6, 7, 8 will be a 1, 9, 10, 11, 12 will be a 1, 13, 14, 15, 16 will be a 1. So anytime it's 3 to a power, or sorry, to a multiple of 4, it'll end in a 1 because we're repeating every 4. So it doesn't matter what the x is as long as we're multiplying 4 times that x. A multiple of 4 will always end in a 1. So if this is brand new to you, if you've never seen this units digit stuff, I flew through this It is something that you'd want to spend a little bit of time on, but once you understand the patterns, these will seem much easier. Every single digit has its own set of patterns, and some of them, so for example, if we look at, let's talk about 4. 4 to the 1 obviously is 4. 4 squared, what's the unit digit? 4 times 4 is 16, so unit digit is 6. 6 times 4 for 4 cubed is 24. So hey, we're back to a 4. So 4s actually repeat every 2. And then some of them, like 5s, it'll just be 5, 5, 5, 5, 5. The 6 will be 6, 6, 6, 6, 6. So some of them repeat every 1. I don't think you have to memorize them. Honestly, I don't remember the order that this goes in. I jot it out quickly every time. But, ooh, someone put a great link in there. Jose, would you mind sending that link to all participants as well as all the panelists? Yeah, there's some great resources that explain. I can also send you guys some blog posts that I have about how to do this unit digit stuff. Thanks for that, Jose. All right. So coming back to here. Some of us thought that the answer was C, when in fact the answer was A. Last one that we have here. Oof, this one, you guys, this one is really, really, really difficult. If you were stuck on how to rephrase this question, someone said, Jose will get into a good business school, I can tell. I agree. Thanks, Jose. So thinking about this question, we've got M, we've got N, we've got X, we've got 3 to the X, 4 to the X. There's a lot going on here, and more than 3 times the value, super complicated problem. Let's start with this. If we didn't even rephrase, tell me some answers that you could rule out. What is definitely not possible? There's no way the answer is going to be A, because just knowing that X is 4 tells us nothing about M and N, so there's no way that's enough. A is out, but then also D is out, right? So here's a question for you guys. What would happen if you put the two statements together? Well, if we know that X is 4, then we can apply that over here and say that M is 3 to the 4 plus 1, so 3 to the 5, and N is 4 to the 5. Okay, so we've got a value for M, a value for N, a value for X. We can definitely answer the question, right? But then, did we use our knowledge of exponents at all? I mean, we kind of just plugged robotically and knew that we'd get an answer because we had all the values. But this problem is clearly an exponent problem. It's trying to get us to think about exponents. So if we picked C on this one, that should start to feel a little icky. It should feel like, wait a minute, it's an exponent problem, but we didn't do any thinking about exponents. There's got to be something more to it. Wait, can you guys not see the problem? Oh, you can see it. If you can't see it, I am not quite sure. Actually, yeah, I'm not. Some of you are seeing it, some of you are not. Charlotte, are you still having a problem with that? Okay. If you guys have any technical issues, just know that we'll always upload these to YouTube, usually within a day or two, so you can always go back and redo it there. All right, so let's think about this problem. How would we write this algebraically? Is the value of m plus n, so m plus n, more than 3 times the value, so more than 3 times 3 to the x plus 4 to the x? Okay. Can we rewrite this stuff? On this side of the equation, or inequality rather, 3 times 3 to the x, what would that give us? If we're multiplying with the same bases, we add the exponents. So 3 to the x plus 1. And then over here, that would just be 3 times 4 to the x. That's nothing special, but we could leave that as is. If we look at statement 2, if m is 3 to the x plus 1, and then n is 4 to the x plus 1, how do I simplify this? Well, we could subtract the 3 to the x plus 1. It's on both sides, so let's get rid of that. And then we're looking at 4 to the x plus 1. Well, really, we could rewrite that as 4 times 4 to the x. And is that greater than 3 times 4 to the x? Yeah, it is. So this gives us enough to definitively say the answer to the question is yes. So the answer here was B. Crazy, right? Super, super complicated. But there's a pattern that we can detect across all 4 of these questions that will help us out. So this would not be considered an easy question. No, someone just asked, is this easy? This would be a crazy hard question. Definitely one of the hardest. Super, super hard question because most people pick C because it's totally reasonable to pick C. If you use the statements together, it works, right? But I want to point out something really important. Just one quick note here. If you have to guess, it's often pretty likely that really complicated statements might be sufficient. So if you don't know what else to do, bet on complicated being sufficient. But when we're thinking about what these had in common, think about this. What happened in each of these if we put the 2 statements together? Well, in every single one, if we put them together, yeah, it would work. We'd have enough. But this is what we like to call a C trap. I want you guys to remember that C doesn't just mean both together sufficient. It's together they're sufficient, but neither alone is sufficient. And here's what's really interesting. Here's what happens in data sufficiency that does not happen in any other question type. C is really tricky. C tends to be overchosen because people forget about the second half of what C means. Think about it this way. If one of the statements is sufficient by itself, I mean, it's also still going to be sufficient if we put the 2 of them together, right? So if you're just evaluating, like, does it work if we put the 2 of them together, you're actually looking at it the wrong way. We need to evaluate them separately first before we put them together. So how do we evaluate exactly what a C-trap means? Well, here's my rubric. If it's way too obvious that when you put them together it's sufficient, and let me even define a little further. What do I mean by way too obvious? Well, if when you put them together you get all the values for all the variables, all the unknowns are taken care of, especially if by putting them together you didn't do any conceptual thinking. Like you weren't thinking about what averages and medians meant. You weren't thinking about how units digits behaved. You weren't thinking about how exponents behaved. Or if you didn't use a piece of the given information. I guess in the last one, I guess we weren't using the structure of the question. But sometimes there'll be ones that you just by picking C, you ignored a piece of given information. That means that the answer is probably not going to be C. And someone said it, Laura said it perfectly. If it feels too easy, it probably is. If it feels too easy, it's worth thinking about twice. That is a great way of phrasing it. Ooh, and just banged my finger on the table. If we know that together it definitely works, the answer is probably not C, but it's also definitely not what? E, right? E is not sufficient even if we put them together. So yeah, we can rule out C, we can rule out E. And then here's how we'd look at the other answer choices if we weren't quite sure and had to guess. So if you're guessing, if you recognize that something is a C trap, if you're guessing, here's how to think about it. If the statements seem equally helpful, pick D. If one of the statements seems more helpful than the other, pick that one. So the D, it'll show up sometimes. Like you might have a situation where, like on a geometry question, the two statements just give you like either side of a line segment or something. And it was asking, if it was asking for the whole length of the line segment, clearly using both together is sufficient. But just one of the pieces in a relationship with other geometric identities might give you that. If they're giving you the same kind of information, pick D. And when we say one more helpful, let's actually go back to our examples. I think in some of these it's clear, like in number 4, you might not have known why number 2 was helpful, but it certainly contains way more information. And statement 1 was just a single value. Statement 2 should pop out as being obviously way more helpful. In these two, I would say it doesn't immediately jump out at me that one's more helpful than the other because they're both equations with two variables. So I just need to rearrange and see which one gives me this. In number 3, a relationship between two variables is always more helpful than just a single variable. I think that's a good just rule of thumb. It's going to give you more information. In number 1, I think it wasn't immediately obvious. In fact, these statements looked like they were giving us exactly the same kind of information, but it was only after probing a little bit that we're like, oh, if they give us that one of them is the average, that is conceptually different from one that's not the average in the way a set of 3 will behave. So really this idea of look for the more helpful statement, mostly applicable to number 3 and number 4 here, but just something to keep in mind. If you find yourself over choosing C, there's probably a reason for that. Questions on this? All right, let me show you another set of patterns. What we'll do with this one though, because I'm worried about us running out of time, we won't necessarily do the full problems all the way through, but I just want you to read through them and think about these two and think about whether you notice any sort of patterns or play between the answer choices. Or sorry, not the answer choices, the statements. So take a moment, read through that, and then we'll discuss in a couple minutes. All right, so I want to take a look at these two. These are both pretty hard problems, so I was worried that if I gave you a couple minutes each on these that it might take more time than we have left. But do this. You can take a screenshot of this and try these out, prove them out later. If you are following along on YouTube, go ahead and pause the video here, give these a try. I will give you the answers in a minute. But I want to just talk about patterns here. Thinking about these, if we look at this first one, X chocolates, Y gummy bears, Z lollipops, we want to know how many trick-or-treaters came. Well, knowing something about the numbers of chocolates and gummy bears and lollipops might help us figure out how many trick-or-treaters there were. But I want you to think about this. All right, looking at the first one, we're given a ratio. Well, if we have a question that's asking for a concrete number, how many trick-or-treaters, and if we aren't given any numbers yet, a ratio is not going to help. We need concrete numbers to answer a question about concrete numbers. So a ratio is not enough. The second statement gives us concrete numbers, right? That seems really helpful. But let's think about this. 24 chocolates, 32 gummy bears, 40 lollipops. We know that we're giving out the same number of chocolates and gummy bears and lollipops to each. In other words, that there has to be a ratio that's constant there. But is it possible that we just had one trick-or-treater and I just gave that one kid tons of candy, right? Never said that the number of trick-or-treaters had to be greater than one. Or it could have been, well, we see multiples of 8 going on, right? Or multiples of 2 going on. There could be lots of patterns here. What would happen if we used the two statements together? 24 to 32 to 40. What is that as a ratio? (24 to 32 to 40), if we simplify that ratio, it's 3 to 4 to 5. These two statements gave us the same information. I mean, slightly different. Statement 2 gave us a little bit more information. It gave us concrete numbers. But statement 1 didn't add anything to it. If we know the numbers, we already know the ratio. So in fact, we just don't have enough. Because it could have been one trick-or-treater getting all of this. Or it could have been 8 trick-or-treaters getting 3 and 4 and 5 each. You get the idea. So this one, a lot of people think, well, if I have a number and I have a ratio, that I'll be able to solve it. But in fact, these were actually giving us the exact same piece of information when we simplified number 2. Number 2 was just a more specific version of number 1. Let's look at the next one. Oh boy. This is so confusing. This style of question, it's just outrageous, super, super difficult. So ignore the question for a second. If you didn't know how to make sense of that question, you've got to come up with a guess. Someone said it makes me want to cry. I love that. I agree. This is an outrageously, obnoxiously complicated question. So I want to even ignore it, because sometimes on test day, you're going to have a question that you're like, I don't know what to do with that. Just look at these two statements. Oops. Ha, gave it away for a second. Come back, look at these two statements. Would putting these two statements together help? N greater than 18 factorial. But then this one's telling me that n is greater than 19 factorial plus change. So isn't 19 factorial already greater than 18 factorial? So if I put them together, statement 1 doesn't give me anything that statement 2 didn't already tell me. It's the same information. So that actually means that the answer C is impossible, right? Because it has to be the case that C means together they don't work, separately they don't work, but together they do work, meaning they add value to each other. This situation is what we call statement overlap. If the two statements give you the same information, overlapping information, if one already implies the other, the answer cannot be C. Like, super simple version of this would be like, what is the value of x? And if statement 1 said x equals -3, and then statement 2 said x is negative. All right, obviously this would be a crazy easy question, but there's no way in that scenario that using them together would ever help, because if you know that something is -3, you already know that it's negative. Statement 1 implies statement 2 already. If that's the case, the answer can't be C. It also can't be just the more general one. By that I mean, like in this example, there is no question out there that could be answered by knowing that something was negative in general that wouldn't be answered by knowing that it was -3 specifically. So even if I hadn't given you the question, I'm not even going to tell you what this question is. The statements are x is -3 and then x is negative. The answer would never be C, but it would also never be B in this instance. Could be A. I mean, if it's like, what is X? It could be, it could be D if the question was, is X less than 1 or something? Or it could be E if, well, it's never going to be E if you know the value, if they give you the value of X, but you get the idea. But it can't be C, can't be just the more general one. Does that make sense? Going back to this one, since we are running out of time, here's what I'll tell you on this. I want you to take a screenshot. I want you to try this later. I will tell you that the answer, as you might have predicted, bet on complicated being sufficient. The answer here is B. Statement 2 was sufficient, statement 1 was not. But it has a really complicated rephrase of the question. I want you to try it out, see if you can figure out what the rephrase is. But I will send you guys, I'm going to quickly pull up a link to, well, actually that, I'm not sure if I'll be able to do that. How about this? Cover your ears if you want to try it yourself, or hit pause on YouTube if you want to try it yourself. But I will tell you that the way to correctly translate this problem is n a non-prime number? That's really our question. And statement 2 tells us that n cannot be prime if it's an integer in this particular range, because everything in that range is divisible by something. So I'll erase that in case you were covering your ears. Try it later yourself, see if you can prove that out. So this idea of looking for patterns is really important. It's not just about getting the right answer to a particular question, yada, yada, yada. You want to make sure that you are connecting pieces, even across different topics, looking at structure, looking at the kinds of mistakes you're making. And more than anything else, I want to emphasize review, review, review. Guillermo knows that. We were talking about review logs. He's been trying out the review log, and hopefully that's making a really big difference. So the one thought I will leave you with, there are only 3 types of people in the world: those who carefully review their math and those who don't. So it's like easily the dumbest joke I've ever come up with, but I'm kind of proud of myself, right? Isn't it pretty good? Dumbest joke ever. Yeah, oh, those of you who want to link to the review log, hang tight. I will get that for you. Just one final thing that I want to mention here. Manhattan Prep offers lots of free resources. If you guys are thinking, I don't know how to go about this GMAT thing all by myself, take a class for free. You can sign up for session 1 of any of our in-person or online classes, totally free. We're not going to try to upsell you. We just want to show you what we're all about. And then we have tons of free resources on our website, so do check that out. Give me just one moment here and I will look up that review log for you. Do, do, do. All right, so this is the spreadsheet that I use. If you look at, so it's in, that link is in the chat window now. If you go back to the lesson that I did on how to get a 700 plus, it was all about how to thoughtfully review and how to learn about yourself as a test taker. And oh, got a request for reading comp lesson next time. I will definitely note that. I know that we definitely do have some reading comp lessons in the recordings, so look back at those, but I will put in that request for next time. So thank you guys all so much for doing this session with me. I hope you learned some things. More than anything else, I hope you learn to step back and think big picture. So good luck to all of you, and I hope to see you next time.